Multiple linear regression with interaction. In this week, we're gonna learn a more complicated linear regression with more variables involved and the interactions between them. Firstly, let's take a look at several terms. Continuous variable. Continuous variables are numeric variables that have an infinite number of values between any two variables. For example, the length of a part or the date and the time a payment is received. Categorical variable. Categorical variables contain a finite number of categories or distinct groups. Categorical data might not have a logical order. For example, the gender, the material type, and the payment method. Previously, we see the example of how to use the continuous variable in linear regression, and the categorical variable can be used in linear regression as well. When we want to use the categorical variable, we need to ensure that each category is assigned to a numerical value. So often we label binary variables as 0 and 1, and the 0 will be the reference category. For example, the gender. 0 represents female and 1 represents male. 0 is the reference category. And then here is the example of run the linear regression model between the categorical variable. The outcome or the dependent variable is the walking distance. And then the dependent variable is this is the dependent variable, and the independent variable is the gender. And when you run the summary of the model, this is the outcome of the coefficients. Based on the coefficients, we can build out our model. That is the walking distance equals to the alpha, which is 379.7, plus the beta, which is 30.5 times gender. The regression coefficient for gender represents the expected change in our outcome walking distance for 1 unit increase in our predictor. And then look back at this example. When the gender equals to 0, that means this is the female, and the walking distance equals to the alpha. When the gender increases by 1 unit and the gender equals to 1, that means it's the male. Then the walking distance gonna be the alpha plus the beta times 1, and then we can get around 410. That means for the male, the average walking distance equals to 410. And we can definitely change the binary value for the gender by using the 1 represents female and the 0 represents male. Then the equation gonna be changed like that. Alpha equals to 410, then beta is still the same, however, it changes from the above 0 to below 0. That means when the gender increase from the male to the female, that is from the 0 to 1, the average walking distance gonna be reduced by 30.5. So previous example contains only 2 different values in the categorical variables. And over here we have another cap variable that has 4 different values inside of it. That is the categorical variable as well. And the 4 different level is mild, moderate, severe, very severe. And over here, we can use the mild as the reference variable, that reference level as 0, and maybe the moderate is 1, severe is 2, very severe is 3. You can change it whatever you like. So here, when we run the linear regression, again, the outcome still be the walking distance, and the independent variable is still be the categorical one. Then there are gonna be several different coefficients for the predictor. Then we can build up our equation based on that. That is the walking distance equals to the alpha, which is 458 something, then minus beta 1 times the moderate minus the beta 2 times the severe, then minus the beta 3 times the very severe. Then we can see that when the severity equals to 0, that means that is mild, then the walking distance is equals to alpha. And when the the severity increase by 1 value, that is when it equals to the moderate, then the walking distance is gonna be decreased by 51, 0.09. And when the severity equals to the severe, that is it gonna decrease by 89 something. And when it is the very severe, it gonna be decreased by 167. So when we use the mild as the 0, we can see that for every people that has the more severe disease, the walking distance gonna be decreased. And if we use the moderate as the reference, then we set it to be 0, and then we're gonna have another beta, the beta 0 for the mild. And the beta gonna be larger than 0. That is when the severity is mild, it's gonna increase by the beta 0 level of walking distance. The regression coefficients here show how much walking distance changes for the moderate, severe, and very severe, or compared to mild disease. The coefficients are all negative, suggesting that walking distance decreases as disease severity increases, and the magnitude increases with increasing severities. Then the interaction between binary variables. An interaction between two variables means that the effect of one variable on another is also by the presence of a third variable. An interaction occurs when an independent variable has a different effect on the outcome due to another independent variable. Think of it as the third variable influencing the relationship between the predictor and an outcome. So here I have a table, and this is the diabetes. This is the actual fib. We can see there were 21 people who have the diabetes, and there were 20 people who got the actual fib, and 10 people who got both. When we run the linear regression model, we can get the p-value separately for diabetes and atrial fib as long as the interaction of both. And the interaction is still less than 0.05, so we can see that the interaction makes difference for the outcome. And then this is the equation that we can come up with. The outcome equals to the alpha minus the plus the beta 1 times diabetes plus the beta 2 times atrial fib plus beta 3 times the interaction. Diabetes is equals to 0 if not present and 1 if present. It's the same for atrial fib. If I want to estimate the average walking distance for a person who got the diabetes but no atrial fib, then the diabetes is gonna equals to 1, then the atrial fib equals to 0. Then I can put it back to my equation because the atrial fib equals to 0, this part equals to 0, and this part equals to 0 as well. However, for the diabetes, it equals to 1. Then the walking distance equals to the 428 minus 7.7, which is around 420.4. That is the average walking distance for a person who suffer by diabetes but no atrial fib. Then we can also apply the interaction between the binary and continuous variables for the linear regression model. Then the way to run it is gonna be very similar as the interaction between binary variables. Okay, that's it. Thank you for watching.